All right, so we'll start the U-try solution here, number one. I'll work this one out. Again, recognition that it's binomial times binomial. Now, one thing I do want to mention, when students look at this, sometimes I see them go through and try to do an operation that they shouldn't. When they look at this left to right, they see 4 plus 2, square root of 5. And sometimes they try to combine this, 4 plus 2, making it 6. Or 6 minus 4, making that 2. We cannot combine these. Okay, remember, order of operations. This is a multiplication. This is a multiplication. That takes precedence over any addition and subtraction. If this was 2x, you'd say, well, that's not a like term with that 4. We can't combine it. That's the same thing you have to think here. So we cannot combine the 4 and the 2 or the 6 minus 4. So if you make that mistake once, adjust. Here I'm going to do FOIL. 4 times 6 is 24. That's the first. The outer, remember the 4 is not an irradical. So 4 minus 4 square root of 5, coefficient times coefficient, we get negative 16 square root of 5. The inner, 6 times 2 square root of 5, 6 times 2 is 12. Square root of 5 times itself. And then the last. 2 times negative 4 is a negative 8. Square root of 5 times square root of 5 is the square root of 25. Okay, so simplify where we can. We can't do anything with 24. Okay, these are like radicals. If we have the same index, same radicands, we can combine the coefficients. So negative 16 plus 12 gives us negative 4 root 5. Well, square root of 25 we can evaluate. Square root of 25 is going to be 5, so I have negative 8 times 5. So I have negative 8 times 5 is negative 40. Well, combined like terms, these are still like terms. So 24 minus 40 is negative 16 minus 4 square root of 5. Remember, this multiplication takes precedence, so we cannot combine these. This is our solution. Or we can have negative 4 square root of 5 minus 16. Okay, I got to rewrite the other problem as we had it. It's on this sheet. So we had square root of 20 plus the square root of 18 times square root of 10 minus the square root of 27. Okay, now you can look to simplify within each one of these and make them look similar to what we have here, or we can just jump into the distribution. The index is matched, so we can multiply the radicands. Square root of 20 times square root of 10. We get the square root of 200. Square root of 20 times the negative square root of 27. We get minus square root of 540. 18 times 10. We get the square root of 180. 18 times 27. Calculator. We get 486. So minus square root of 486. 486. Now remember, we cannot add or subtract the radicands, so we cannot combine, say 200 minus 540 plus 180 minus 486. We cannot do that. Cannot add or subtract radicands. We want to look to see if we can remove factors. I don't know why I showed my calculator up because I wouldn't need it. Okay, so 2 times, or 200. I know that is, I want blue. I know that's going to be 2 times 100. So 2 times 10 squared. I can take that 10 out. So I get 10 root 2. Okay? In 540, do I have, so I can divide by 4. If 4 goes in, which it does, is 4 times 135. 540 divided by, if 4 goes in, I always try 16. It does not go in evenly. So I get 2 squared times 135. Now, if it ends in 5, you can generally try division by 25. I divide by 25, it doesn't go evenly. But if I take 135 and I divide by 5, this is 5 times 27. Well, in 27, I have 3 squared times 3. So I have 2 that come out, and I have a 3 that comes out. So when I take those out, we will multiply. Now, because I can take a 2 out and a 3 out, I could have taken 540 and done a larger. I could have divided by 36. I would have had 15. So 5 times 3 is that 15. So I'm going to get minus 6 root 15. So this here, I'll put a check mark by it, that stays inside. 5 times 3 stays inside. These are not like radicals. We're not going to be able to combine those. Let's see what happens with the 180. 180 I can try dividing by 4. It goes in 45 times. Okay, so 180 divided by 9, it goes in 20 times. So I did 4, I did 9. Anytime I can do divide by 4 and divide by 9, I can divide by 36. And I saw that as I represented that. Try to find, you can do it in pieces like we did, or we could try to find a larger chunk. Things I look for. If I can divide by 4 and 9, 36 is going to be in there. If I can divide by 4 and 5, 100 is usually going to be in there. So if I divide 180 by 6 squared, I get 5. So I'm going to take a 6 out. So this is going to be plus 6 root 5. I don't have another like radical. Okay, so 486. Okay, so as you look, again, you can divide by 4. It doesn't go in evenly. Divide by 9. It goes in, but look at this. I have 18 and I get 27. I know this is 9 times 2. I know this is 9 times 3. So 486, because I had 9 times 2 and I had 9 times 3, I have 9 squared. So that's 81 times 6. Sometimes you can look back at the numbers and see, based on these smaller numbers, you're going to know what factors are there. Just try to remember, if we were dealing with square roots, we want to account for 2 of them. So that's why I saw the 9. So I can take a 9 out. So I have minus 9 square root of 6. So I have 10 square root of 2 minus 6 squared of 15 plus 6 squared of 5 minus 9 squared of 6. All the indexes are the same. They're all square roots, but none of the radicands match. That is as far as I can go then. So this is our answer. In any order, you could have that. Okay, so those are you try problems. Remember, you can put them together, look to break them down. Sometimes as you go through, you can do it in small chunks. You can look to do it in larger chunks. Just work your way through that process. Okay. When we come back for the next clip, we will work on some special products here.